All right, good. Thank you. So, let me just run again very fast. Just want the output maybe here. See how the data. So yesterday we discussed about the first part. Okay, we discussed about the first part. Um, So the first part was about now the summary output. We talked about multiple R. We say this is the coefficient of that is correlation or correlation coefficient. Then we also discussed about R squared, and we say this is coefficient of determination, and it helps us to that is to check the goodness of it. Okay. Also, we said standard error might help us to know maybe the goodness or to determine the goodness of it of maybe a certain what model. Okay. Then for adjusted R squared, we said more so when we do hyperparameter tuning, we might now get a different that is that is R squared. Mostly this happens when we are using multiple linear regression. Okay. All right. Now today we were to start from the what? From the that is from Anova. Okay, we were to start from Anova. So for Anova, we'll discuss about degrees, or that is degrees of freedom. Okay, remember we use majorly when we back in what high school, we were dealing with what we call degrees of freedom. Like for example, when we said maybe a certain data is that is follows a chi-square distribution, okay, with n minus 1 degrees of freedom. Okay, so basically the degrees of freedom, um, we usually use maybe the n minus what? The n minus 1. Okay, yes. So then we also have some of squares. Okay, we have mean square. Okay, and then we have f statistic. Okay, f statistic, this is a f test value. Okay, this is f test value, and also we have f significance. Okay, f significance and f statistic. Okay, then we also now when doing analysis of variance, we usually that is compare the f significance with p-value. Okay, with p-value. P-value basically it's a probability trying to show us the that is the significance. Okay, this if our model is what is statistically significant. Okay, like it is it is statistically making sense. Okay, so we'll see how we can determine or how we can know that is uh, a model. Okay, is what is statistically significant. Okay, so we'll compare significance f and significance f and also the p-value to know. Okay, so p-value, will use a p-value of 5%. Okay, 5%, meaning it is 0.05. Okay, yes. So if any case the value of significance f is less than 0.05, then it's we can conclude that that is a model is statistically significant. Okay. Yes. Then we already discussed about coefficients. Okay, now maybe you can go and check about the upper, lower, and yes, lower quartile. That is, if it is lower quartile, upper quartile, all that. Okay, yes, for this you can go and discuss it, but for me, I'll discuss more majorly, that is about f significance, f value, mean squared, and then only this. Okay, the analysis of variance. Then maybe you can go and study much about this. Okay, yes, just as an assignment. All right, so I would like maybe now to go to our PDF so that I may explain, okay, as we go through. Right. Okay, so basically we saw this, these are our coefficients. So don't worry about the difference. It's because there are some values which I updated. Okay. Yes. All right. So in this case, I would like us to start with the. Yesterday we discussed about the what? The output part. We discussed about multiple R, R square, adjusted R, standard error, and observation. So today I want us to discuss about what? Analysis of variance. Okay. Yes, so the second part of the output is analysis of variance, which is ANOVA. Okay, so basically, ANOVA is that is it splits the sum of squares to individual components. Okay, that gives information about levels of variability within what? Within our regression model. So the first one is always the degree of freedom, okay, which is df. It's the number of degrees of freedom associated with what? With the source of variance. Okay, like for example, in our case you can see the that is the degrees of freedom, it is n minus what? It is n minus 1. So n, we know it's our observation, so it will be that is 24 minus what? Minus 1, which is 23. Okay, yes, with that maybe I can't remember like what degrees of freedom really shows, but with this we can check. We can just check online. We'll see, check together. It's long time since I handled the topic on degrees of freedom. Okay, but for the others, I am aware. So we have sum of squared methods or sum of squares. So of course, now whenever, okay, you find that that is residual, or the sum of squared of residuals is smaller, way smaller than the total that is sum of squares, then we also, it's another way we can try and see if our model fits our data well. Okay, like like of course it will be always smaller. Okay, remember that residual, that is a residual, will always be small than what? The total, that is the total sum of squared. But the smaller, okay, you can see 3000 compared to 280, it's very small. So the smaller the residual, take note of that. Okay, not the small, but the smaller. The smaller the that is the residual sum of squared, okay, compared to the total, that is sum of squared, the better your model fits the data. So that can be also another that is a method. Okay, that can be also another method to determine what? To determine that is the goodness of fit of what? Of our model. Okay, then we have the mean square. Okay, so basically mean square, it is like the like it's like we are trying to do what? To find the mean square of what? Of our values, okay, or of our variables. Then we have f statistic. Okay, so for f statistic, always assumes that, or always assumes null hypothesis. Okay, it always assumes null null hypothesis. We'll learn more about hypothesis during the hypothesis topics, that is the topic that is inferential statistics. Okay, so but basically null hypothesis always hold that there is no significant difference. Okay, there is no significance difference. That's what always the null hypothesis odds. Okay, like we don't have any significance difference between maybe the components which we are trying to measure. Like for example, if I am creating two hypothetical scenarios, like for example, we are investigating that is the Q, that is intelligent quotient IQ of a statistician and a motorcycle rider. Okay, I don't want to say that motorcycle riders have that is low IQ, because we even have learned what? Motorists. Okay, yes, so what we can say that even from the hypothesis, okay, so a null hypothesis will assume that there is no difference in what? In IQ. There is no significant difference between what? Between the IQ of these two people. But alternative hypothesis will now that is be the opposite. Okay, like it will show us there is certainly there is that is a difference. Okay, certainly we have a difference between what? Between the IQ of the what? Of the two people. And then you can go further and do analysis and see if maybe the statistician and the motorist who has what? Who has that is the highest that is IQ. Okay, yes, so that was just a scenario to show you how that is a null hypothesis states. Okay, yes, so f is the f statistic. You can go and learn about f statistics and also t statistics. So these are some of statistical tests. Okay, they are statistical tests. What are statistical tests? So basically statistical tests tries to show us if whatever maybe whatever thing you are doing, or whatever model you are creating, if it statistically makes sense. Okay, if it is really making sense statistically. Okay, if it doesn't make sense, definitely we also have an indicator. Okay, to show that this model statistically does not what? Does not make sense. Okay, yes, so f is the statistic, or the null hypothesis. Even before we can continue this, let me try and that is define these two values. Okay, all right, so we have the p-value and then we have the f value. Okay, so let's start here. So f value, it's a value of f distribution, but just don't think about f distribution. It's more of the now the f statistic. There is a formula which it's used to calculate f value. Let me just confirm. Let's confirm together. Formula for f statistics. So the formula is always this one. Okay, so like for example, you can see f statistic, which that is the critical value of this test. The f statistic formula is given by variance of the what? Of the group mean divided by mean of the within group variance. So basically, like for example, I'm trying to check now. That is the best formula. We usually have this formula. I guess it is this looks better. Yes, so you can see this is formula for variance. Okay, for sample variance. Remember this formula? Yes, I guess you can remember this formula. For sample, this is sample variance. Okay, and you can see now the formula. It is for f statistic is variance of the first value divided by, that is of the first variable, divided by variance of the what? Of the second variable, which is this, like you can see this variable. In fact, this formula explains it better. Okay. No. So you can see from this formula, okay, like we have um, variance of what? Variance of the first or of variable x divided by variance of variable what? Y. Okay, so remember we have 1 over n minus 1. This is the variance, how we calculate the variance. So this is how we calculate the variance of the first variable. We also calculate variance of the second variable, and then we take variance of x variable divide by variance of y variable. Okay, that's how we get what? F statistics. That is statistic. Okay, that's how it is calculated. Yes, it's the same thing as this. Like if you take now this, compute for the first variable and also compute again for the second variable and divide by 2, then you will get what? You'll get that that is you'll get that value. Okay, you'll get f statistic. Okay. All right, that was just an explanation now on how we calculate the f value. So, variance, okay, variance statistical test, that is various statistical test generate what? That is a f value. The value can be used to determine whether the test is statistically significant. Okay, so the f value is majorly used in analysis of variance. It is calculated by dividing, that is two mean squares, or let's say two variances. Okay, dividing two variances. Okay, so in that case, um, you can see now we will have what? F value. Okay, and f value helps us to do what? To determine whether the test is statistically significant. And this is when you compare now it with what? With the p-value. Okay, when you compare it with the p-value, then we have now the p-value. Of course, from p, probability. P meaning it's a probability value. Okay, p value, it's a probabilical that is value. So it is defined as the probability under the assumption that there is no effect or there is no difference, like it is supporting what? The null hypothesis. Remember, the null hypothesis states that there is no what? Significant difference. Okay, no effect, that is a difference between what? Between the two variable. Okay, so we can say that is a probability under the assumption that there is no difference of obtaining a result equal or more extremely than what actually observed. Okay, so the p-value stands for probability and measures how likely it is that any observed difference between groups is due to what? To a chance, like it happens by what? By a chance. So basically, now the p-value, it's the value which we'll try to see, do we have any statistical significance? Okay, so any value which is less, we are saying that any p-value less than 0.05, here we usually say that is we have statistical significance. In what? Significance in our model. Okay, any p-value, okay, or any f value, sorry, any or any p-value which is greater than 0.05, then we say that we have no, that is the data, all the analysis is not supported by statistics. Okay, all the analysis is not statistically significant. Okay, all right. So basically, going back to our notes, so we are saying that F statistics, okay, or F test for the null hypothesis is used to test the overall significance of what? Of our model. And we compare, that is the significance F, we compare significance F value, which is the F test, okay, with what? With the p value, to know if our model is statistically significant. Okay, so significance F, okay, significance F is the p-value of F. Okay, significance F is the p-value of F. So that's why even from our results, you can see the significance F is taking what? A very small value. You can see it is 2.07 raised to 10 raised to what? Negative 13. Meaning we have 13 decimals before what? Before the 2. Okay? Alright. So we can say now that the ANOVA part is rarely used. Okay, so the ANOVA part is rarely used when you are dealing with simple linear regression analysis in Excel. Okay, but you should definitely have a close look at the last component, okay, which is the significance F. The value gives us an idea of how reliable our model is, or how reliable our that is our results are, or how statistically significant our what? Our results that is our results are. Okay, yes. So significance F values gives an idea of how reliable or how significant, that is statistically significant, our results are. Okay, if significance F is less than 0.05, we can call this p-value. standard p-value. Okay, so if significance f is less than 0.05 or 5%, then we usually say your model is okay, or your model is statistically significant, or it is reliable. Okay, it can give us desired what, or desirable results. Okay, yes, and we can have confidence, okay, when now using our values or our results to do what? To make a conclusion. Why? Because they will be statistically significant, okay? So, if it is greater than 0.05, you would probably better, that is probably better choose another independent variable. So basically, if the p that is the significance f value is greater than 0.05 or greater than 5%, then we will have to do what? We will have to go back, find another independent variable which can give us that is better results. Okay. Yes. Then from yesterday, I guess this part I had explained it. That is the model, how we are fitting the model. You can see how we are fitting the model. Okay. And we even also forecasted what? Forecasted that is one variable. Okay. We even forecasted one variable. All right. All right. Any question up to that point? Any question up to that point? By show of thumbs, if we are together, you can. Okay, Duo, Otieno, Wangui, Deborah. I've seen only 5. David, Steve King. Hello, Elisha. Long time. Long time. It's long. It has been long since we had you in this class.
Yeah, hello. 2 years indeed. It has been long. Uh, I'm sorry. We went for some research trip outside the country, so I had got some. I couldn't have some time to attend, but I'm back. Sorry for that.
No
uh,
problem. I hope you are also following the class
yeah,
recordings.
yeah, yeah, exactly. They're helping me a lot. Thank you.
Yes, they are very important. They are very important because you'll be surprised. That is for the final certification exam. You'll find maybe whatever we are discussing here, it's
Yeah.
whatever will be tested. Okay.
Okay. Thank you so much. I'll ensure I follow all of them.
Okay, no problem.
Thank you.
All right. Okay. I hope we are good up to that point. So now with that, I will go to the other that is method, or our last method, which is using what? Using inbuilt. Okay. Using inbuilt Excel functions. Okay. So we have different that is I guess 3 methods or 3 functions which can help us now calculate all this. We have something known as lean set. I guess it is lean set. Then we have slope, and also we have another function called intercept. Okay, let me just confirm the first one if it is the true spelling. Yes, it is the true spelling. So we have linset function, and this linset function basically uses the least square method, regression method. Okay, we have that formula already inbuilt into what? Into that that is into that function. Okay, we also have slope. So for slope will give us that is the constant attached to the what? The constant attached to the x variable. Then intercept, of course, it will give us the normal intercept. Okay. Then for Corel, basically Corel shows us that is the correlation, and I guess we used Corel function when we were discussing what? When we were discussing correlation topic. Okay. Yeah, so we are going to check the lean set, the slope, and the intercept. Okay, and then we will be done with what? We will be done with the regression analysis. Okay, practical, but I will also give you an over that is a bonus of the two function, that is forecast linear and trend for that is formula. See how we can forecast maybe future sales or umbrella sales given a certain amount of what? A certain amount of rainfall. Okay. All right, so let's start with the first formula. So the first formula, it is the lean set. So if you write lean set, you will see that lean set returns statistics that describes a linear trend matching non-data points. Okay, by fitting a straight line using the least squared method. So basically here, the values which you are going to get, we are going to get only two values here, or only two outcomes. We'll get the slope, or the first constant which is attached to x variable, and the y-intercept. Okay, yes, so with that we'll go to lean set. If you that is write the formula it will guide you. Okay, it will itself guide you. Like for example, you can see we are told now to highlight or to input the non-wires, meaning wires, meaning they are all these values, and then also we do a comma and give what? Non-axis. Then once we are done that, we can now run and get our values. Okay, so with that, I'm going to highlight our what? Our y's or our y values. Okay, then do a comma. All right, sorry, did not do a comma. Yes, so after that, we can now do a comma. All right, once we do now a comma, we'll come to our non-axis. So we'll also highlight our what? Our x values. Okay, then we can close and then run. Okay, no, it has not given me the desired that is output, because for this it should have given me two values. Can someone try and see if you are getting that is two values, or you are getting one value? Maybe it's because my Excel, I saw it needs like updates. Can someone try from your side and see if it will give us two values? Because it should give us these two values, like it should give us two values once. Okay, it should give us two values once. Let me try it again. So we have lean set. Okay, then I will highlight those values, then comma, go to x values. Okay, and then run. Still giving me one value, but it should give me two values. Someone who has tried it? it should output two values. That is this value, which is the slope, and it should also give you another value, which is that is the y-intercept. I don't know why it is not working, but maybe we can also as well continue with the two other formulas. Okay, in case maybe I want the slope, okay, and I want the y-intercept. Okay,
No, sir.
yes.
Mine is giving two digits,
Uh-huh.
-18 and 0.48.
Yes, it should return two values. Yes.
Yes.
So, and if you check those two values, they are the same values which we got here.
Yes, yes.
Yes, right?
Right.
Yes, so those are the two coefficients. It should at least return two values. I don't know what's the problem with my Excel today, but it should give us two values. Okay? All right. Good. Now, if it gives you two values, you can now therefore maybe create the model in this manner, like the way we did with the first methods. Okay, like this one. You can create your model like this one. Okay, you can create your model like this one because you have the slope and you have the intercept. Okay. Yes. Then you can as well calculate that is those two values separately, like come and write slope. Okay. Once you click slope, you can see the slope also needs you to insert non-y's and non-x's. So you'll as well do the same. Highlight the non-y's, then do a comma, and then highlight what? The non-x's. Okay, and then run. Once you run, you can see it will. You are getting all the same form. That is the same value. Then for intercept, you can just write intercept. You can see here we have the intercept. Then under intercept, you can also see it needs you to insert what? The non-y's and the non-x's. So you as well highlight the non-y's, okay, comma, then the non, that is that is x's. And then once you run, you can see it is also giving us what? Negative 18.91. Any questions up to that point? All good? All good? All good? You can just show me thumbs up so that. All right. Okay. I can see now we are all good. The remaining part now. Let me add you the bonus. Like for example, I might decide um, to forecast. Okay, to forecast maybe the umbrella cells. Okay, and how can I do that? Maybe I would need the rainfall amount, okay, for the next year, that is for 2018, because I have 2017 and I have 2018. Okay, I need now the values for umbrella cells. So we will assume we can now take the monthly rainfall average, okay, and assume that it's the what? It's the rainfall amount which we'll get in the what? In the following year. Okay. So in that case, we can just find the average rainfall amount. Okay. the average rainfall amount for this, that is for the rainfall, okay, for the rainfall. Yes, let's say for the rainfall amount, okay. All right, so how can I do that? Okay, so what I will do, I can use that is one formula. Let's say average if, okay. I will use average if. All right, we have the range. I will average this. I will average this, okay. Then I will lock this. I will ensure I do what? I lock. I will ensure that is I lock this range so that it might not change. Okay. So I want to average if. Okay. Which criteria? January. Okay. Average if January. Let me try and see. All right. All right. Something. I did the that is the range. I did it I did it in the wrong way because I only, okay, I should have taken this range together with what, together with the month name. Okay, then I can do what, I can lock and see what value I will get. So for this, it might not work. I might now be pushed. I might now be pushed to use more than what? More than one criteria. So I will have to use average ifs. Okay. So average ifs. So you can see under average ifs, I have average range, which is our data range. Then we have the criteria, which is our that is our it's our range, that is the month range. And then our last criteria will be what, now this whatever we want to do the average. So it will be average ifs, average range. So our average range will be this one up to that point. I can as well lock, I can lock that average. Okay, then I'll do comma. Then you can see criteria range. So we need the criteria range. So this is the criteria range. Okay, as well you can do what, you can lock it. Okay, so that it might not change. Then comma. Now we need the criteria. Okay, now the criteria will be January. Okay, or will be this, and then I can close and I can run. So you can see it is at least giving us what, value. Okay, so what the formula did, it came red, or that is the Januaries. Okay, the Januaries here, it added these two values, this value and these values, and it divided by 2. It did an average. So you can see we are saying equal to this plus this. Okay, you can just close this, divide by what, divide by 2. You can see the value which we got here, it's here. The reason why I used the formula, it's because I just wanted not to use the formula and drag it down to autofill the what, the value. So basically you can see here it is taking the, that is 104 plus 99, divide by 2, and you get this value. So this is how maybe we've determined the amount of rainfall which maybe we can expect in what, in 2018. Does it make sense? Is it making sense? Okay, Mohammed. Yes, please, if you show me the thumbs up, at least that's how I will know we are together. Okay, now it makes sense. All right. Now the remaining part will be now forecasting the future what? It's now forecasting the future, that is the future what? The future amount of, maybe amount of, or the umbrella cells. Okay, but even before we can continue, let me try and check if I or if I take that assumption, if it will give me the same pattern. Oh yes, you can see for the last, that is for the last month, it is also following the same what, the same pattern. So you can see this was for the first year. Okay, this was the that is this was for the second year until here, and this was also for the third year, which we've included here. Yes, it makes sense. The pattern, at least we have the same pattern. All right, now I want us to that is forecast. Okay, so we have two formulas which we are going to use. We have that is the linear forecast. Okay, we have forecast linear. This is the function which we will use, and you can see it calculates or predicts a future value along a linear trend using existing what, existing values. So we are using historical data to predict about that is the future sales. Okay, so with that we are going to use that is forecast dot linear. Okay, and forecast dot linear, you can see we are needed to insert maybe the value of x, which is now our rainfall or our independent variable value. Okay, then we'll be needed to that is use the non-wise and the non-axis. Okay, so in this case we need the non-wise and the non-axis. What are the non-wise and non-axis? Our non-wise and non-axis, they are our what, existing values of y and x. Okay, so we are trying to make the forecast depending with what, the historical data. Okay, so in that case we are going to select our non-wise. Okay, so we'll select this data from that point up to that is the January of 2016 to December of 2017. Okay, then after that you can do that is a comma, and then go to what, to non-axis. Okay, so for non-axis we'll also highlight now the non-axis. Okay, with the same range. Okay, and then we can close. But if at all we want to drag, okay, we'll have to lock these two ranges, ranges for non-y and range for non-axis. Okay, so with that you can just lock it. Okay, you can just lock it. All right, and then we have that. Okay, then we can drag these values, and then we can just make it to be what, to be that is whole numbers. Okay, yes, so you can see now these are what, these are our forecasted values. Okay, these are our forecasted number of umbrella cells. Okay, let's try and see if we'll have the same trend. Okay, so and see if it really makes sense. So I'll come to insert recommended. Yes, and I can see it is making sense. Like the moment the amount of rainfall is increasing, okay, so does the umbrella cell. So you can see we are having the same trend. Okay, so we can say our forecast is it is making sense. Okay, our forecast is making sense because we are having the same pattern as what, as per our historical that is data. Okay, that was now using forecast.linear. Okay, what if we use trend? Let me just copy these values and paste them here. So for trend, we are going to just get the same from that is the same values but different approach. Okay, so we can use now trend function, okay, to forecast. Okay, now for trend, that is for the trend values, you can see we are now starting with what? With non-y's, then non-x, and then we'll come to our new x value. Okay, so with that we are going to select the that is the non that is the non-y's. So non-y's, I'm going to select the non-y's, then comma, I will select the non-x's, okay, then do a comma, and then our new x, okay, and then close. Then remember to lock or reference this that is cells, all these ranges, because they are not changing. Then you can run. Okay, once you run, you can see we are getting what? We are getting the same values. Let me just round that is run to whole numbers. Okay, so you can see we are getting the same value. Okay, we are getting the same values. You can see we are getting the same values. Let me just expand here and see if we are getting the same values. Okay, you can see we are getting the same, almost the same values. Let me try and see if it is true. So this is equal to this. It's true. You can see all the values are the same. Okay, all the values are the same, I guess, except this. I don't know why this. Let me this and this. Let me just copy this and paste it here so that I can investigate the difference. So this, you can see this as very that is huge, that is data set. You can see this is ending with 2, okay, but this is ending with 1, like a very minimal deviation, but all the other values look the same. That's why you can see they have returned true. And then that's all. Any question? Are we together up to that point by the